Lesson 9.1 is going to go back to, again, things you've learned in Algebra 1. We reviewed them in geometry. So we are going to start working with those rational expressions. Remember, these are the fractions with variables, and we are going to talk about multiplying and dividing. So rational expressions is the ratio of two polynomials. So this is where we're going to have those multiple factor, those x squared, x, p to the 5 kinds of things. A rational number is a fraction. Okay. So the ratio of two polynomials is a rational fraction. That's just a little explanation. If we had a problem like 12 over 8, we would always simplify it. So 12 over 8, if we think in the simplest form, what common factors? Well, I see 4 times 3, and I see 4 times 2. We know that 4 divided by 4 is 1, and that leaves 3 over 2. This is exactly the concept we are going to do, except now the things that we are going to be crossing out are going to be things like x plus 3 over x plus 3. And remember the golden rule, we can only cancel next to multiplication. Never cancel next to addition or subtraction. Okay, it has to be a multiplication problem, and you have to cancel entire quantities if you're going to do that. So let's look at some examples. If I want to simplify this, this needs to be factored. So I have 3y times y plus 7 all over y plus 7. This is a difference of perfect squares. Y plus 3 times y minus 3. And that's something that you need to start recognizing. We always simplify by factoring first. Factor completely. Because that changes addition into multiplication. Then and only then can we cancel. So x plus 7 and x plus 7 are exactly the same. They are single numbers because of these parentheses, so I can divide those out. I cannot cancel that 3 or that y with either of the ones down here because those are not identical, and so I'm left with 3y over y plus 3 times y minus 3. And that is in lowest terms. Now, undefined is when it can't exist. And our biggest area that things can't exist for fractions is when the denominator equals 0. So you have to think to yourself, what values would make y plus 3 equal 0 or y minus 3 equal 0? Well, it would be if y was negative 3, it would equal 0, or y equals 3 would make it, if I solve these two, would make it equal 0. So our conditions is y can be anything except y cannot equal 3 or negative 3. Those are the restrictions. I can put any value I want except those two, because if I put either of those two in, it will make the denominator go to 0, which is undefined. It can't happen. So simplify each expression. So first we're going to factor. Number 1 factoring rule, greatest common factor, and then any of our special factors like perfect squares, and then we go to trial and error. So when I have a binomial, when I have a two-term thing, I'm looking for greatest common factors. A to the 4th and a to the 4th are common factors, so I'm going to pull that out front. That leaves b minus 2. The denominator, a cubed, is a common factor, and that leaves 2 minus b. Now the first thing that I'm going to cancel is I have 3 a's here and 4 a's there, which is going to leave 1. So now I have a times b minus 2 over 2 minus b. Now this b minus 2 and 2 minus b are almost the same. So a cool little trick is I can factor out a -1. And so what I'm going to do is I'm going to leave the numerator, a times b minus 2, and I'm going to take a -1 out. And when I take 2 divided by -1, I'm going to get -2. And if I have negative b divided by -1, I'm going to get positive. If I think about rewriting this, this is really the same as that. And so now b minus 2 cancel. This negative can float top or bottom, so I'm really left with negative a, and there are no restrictions because I don't have a denominator. Now if I look at the next example, very similar. I'm going to go ahead and pull my greatest common factor of x to the 4th, and that'll leave me y minus 3, x cubed, and I have the exact same problem happening. 3x's and 4x's cancel, leaving me 1 in the numerator. If I pull a -1, this time I could pull it out of the top. If I say -1, that's going to switch my signs, essentially. Now those two are the same, and what I'm left with is -x. And that is as low as I can get it, and there are no restrictions because I don't have a denominator. Now to multiply rational expressions, very simple. Numerator times numerator. Denominator times denominator. And a lot of times I won't actually even do the multiplication. I will just smush them together into a single fraction, do my canceling, keep my number smaller, and then do any multiplying at the end. So let's look at an example. I'm going to go ahead and write this as a single fraction. I have 8x times 7y squared all over 21y cubed times 16x cubed. So now I can go ahead and I can cancel 7 and 21, have a common factor of 7, that leaves 3 in the denominator, 1 in the numerator. 8 and 16 cancel, leaving 1 and 2. 8 divided by 8, remember they're not disappearing, they're turning into 1. If I think about the variables, x and x cubed cancel, leaving x squared in the denominator. Y squared and y cubed cancel, leaving y. Now it appears there's nothing left in the numerator, but remember there is a 1 there. And so I have 1 over what's left, 3y times 2x squared. Clean it up, 1 over 6x squared y. What can't x and y be? My restrictions? Well, the only thing, remember we're thinking, what would make 6x squared y equal 0? Well, if x were 0, it would be, and if y were 0, it would equal 0. So those are the two values that x and y cannot be. Got an additional example here. If you want to go ahead and assume, we can do like this, save ourselves a writing step. As long as it's multiplication, we can go ahead and do this. Now there's no sense in saying x squared in order to cancel, but if I have two x's, they will cancel with two x's. I have one y and one y, that cancels. I have one y here and 2 there, that's going to leave 1. I have 1z and x cubed, can't cancel. But 3 and 6 cancel, leaving 2, and 5 and 10 cancel, leaving 2. Be very careful and very neat with your handwriting so that you don't forget one of those. When I clean it up at this point, I have 4y x cubed all over z. What are my restrictions? Z is my only variable, so we say z cannot be 0. Tune in to the part 2 of the video to talk about division.